Of all the worlds in the solar system, Jupiter distinguishes itself as the most gigantic in both scale and weight. It is undeniably a remarkable planet, yet due to its vast gathering of matter. Of all the worlds in the solar system, Jupiter distinguishes itself as the most gigantic in both scale and weight. Although Jupiter is mainly made up of gas, a concealed nucleus lies beneath its immense layers. Of course, it is highly unlikely that we will ever be able to reach it. Yet what might such a world hidden within Jupiter actually resemble? Jupiter's remarkable diameter, about 139,140 kilometers, is so immense that over 1,300 Earths could be enclosed within its volume. Through the vigilant observation of NASA's Juno spacecraft, we gain breathtaking visuals of its stormy cloudscapes. Taken from nearly 15,000 kilometers above the planet's upper atmosphere, the imagery is so detailed it resembles masterpieces of art. This viewpoint brings us nearer to the gas giant than any Earth-based geostationary satellite ever could. Enormous tempests arise like the Great Red Spot, which has persisted for hundreds of years. This occurrence highlights the remarkable dynamism of Jupiter. Beyond being the biggest planet in the solar system, it astonishes with traits that remind us how much is still left to uncover. The descent toward Jupiter's core is a voyage that tests not only our creativity, but also the very principles of physics as we understand them. On the observable surface, we witness chaotic clouds, yet the deeper we descend, the atmospheric pressure steadily intensifies. Hydrogen, typically familiar to us as a gas, starts acting strangely under the relentless rise of pressure and heat. What was once thin atmosphere turns into a realm of immense pressure. Within this extreme setting, liquid hydrogen experiences a dramatic change, turning into metallic hydrogen. In this form, it gains metallic traits, including the capacity to transmit electricity. This vast layer of metallic hydrogen is among the key factors behind Jupiter's powerful magnetic field. Despite the overwhelming pressures and scorching temperatures reaching thousands of degrees, Jupiter's core continues to be veiled in mystery. For example, whereas the pressure in the Mariana Trench reaches around 1,000 atmospheres, on Jupiter it surpasses millions of times the pressure at Earth's sea level pressure. So what might that immense planetary core actually be like? Researchers think it consists of dense elements, likely in a solid or partially solid form, with a mass reaching up to 25 times that of Earth.
Let's push the simulation.
This dense rocky nucleus took shape billions of years ago during the solar system's infancy. As its mass increased, it started pulling in lighter gases like hydrogen and helium. This process gave birth to the gas giant we observe today.
If we
Still,
adjust for the magnetic
doubts
field anomalies,
persist
the
regarding
core's
its
density
precise
shifts significantly.
dimensions,
But wouldn't that
makeup,
contradict
and
the
even
seismic
whether it
wave data we
truly
collected last
exists.
quarter?
Cutting-edge simulations indicate it might span between 18 and 25 Earth masses, representing roughly 5% of Jupiter's entirety. This core is thought to consist of concentric strata made up of diverse substances. At its heart, there might exist a metallic sphere of iron and nickel, resembling Earth's inner core. These strata endure pressures that may climb to 3 million times that of Earth's atmosphere. In that region, temperatures could soar to nearly 20,000 degrees Celsius. Certain scientists propose that the core might be gradually dissolving under such extreme conditions. Yet findings from space probes reveal that the core does influence Jupiter's inner structure. For instance, readings of Jupiter's magnetic field indicate that its core is metallic in nature. Indeed, at such depths, hydrogen turns metallic and gains the ability to conduct electricity. This generates a magnetic field that is 20,000 times more powerful than Earth's. We can envision how gas giants such as Jupiter emerge from early rocky cores, laying the foundation for massive planetary growth. Gravity draws enormous quantities of gas toward the developing planet, sculpting its immense structure. Contrasting Earth's tranquil core with Jupiter's turbulent interior underscores the vast differences in planetary formation. As we descend further, we observe energy surging through the planet's core, radiating light within the darkness. Gravitational pressure molds Jupiter's interior, a force both immense and unavoidable. Energy waves spread outward from the deep core, radiating immense force across the planet. The outer cloud layers above the core emit a faint glow from the underlying heat, subtle yet noticeable. From a broad perspective, the planet's layers, from its core to the outer clouds, are displayed with clear structure. Humanity's miniature probes are overshadowed by Jupiter's immense mass, a stark reminder of our own minuteness. The core radiates in the profound darkness, its mysteries mostly unresolved and captivating. Jupiter's concealed core is unveiled through vivid visuals of its churning storms. Wrapping up the journey, the channel outro invites viewers to like and subscribe. Jupiter drifts into the distance, its glow dimming softly as the tale comes to a close.